Hi, this is Rajesh Mukherjee from Holden Institute of Technology, and I welcome you all in this last session on function in C programming. We already have two sessions on this particular topic, and we have already understood that functions are a modular way of organizing code which enable reusability and readability. We have a discussion that primarily the functions are of two kinds, library function and user-defined functions. The library function are the built-in function like printf and scanf, and user-defined function are the special function which crafted by the programmer to perform a specific task. Today we will mainly focus on two topics in context of function. One is recursion, another one is storage class. Now we know that using function we can break a large code into small sub blocks. Now during the execution each block call another block. Now recursion is a special case when a particular block or particular function call itself. Instead of calling other function, when a particular function call itself, it's called recursion. Let's understand this particular topic. So see that we are suppose we are going to write a program to calculate factorial of a given number. So for that, what we could do, let's start from the beginning. We will create a user defined function. We will give the name of the function is fact, and that function will take an input, basically the whose factorial it's going to calculate, let's say n, and after computation, after performing a task, it will return the factorial of the given number. So return type I declare as a int. Now also I declared a particular variable result to store the result, and then we are taking a for loop where I declare an variable I starting with 1, where I less than is equal to that particular number, I plus plus. Now two things we need to do. We need to initialize the result with 1, and apart from that we also declare the variable I as what we are using as an index variable for the for loop. Now what we will do, we will calculate, we will multiply all the numbers starting from 1 to that number, which is nothing but a factorial of that number, and we will return it back. So result is equal to nothing but result multiplied by I, right? And then when we do have the factorial, we will return it, return the result, because we are storing the result, storing the factorial of the given number inside the variable result, so we will return that. Now after that we will create our main function. In the main function, definitely we are going to declare a variable, suppose a is equal to 5, and we will call, also we will declare of another function variable r. Now we will call this fact and provide the value 5, value a, and ask to compute the factorial of value a, and it will definitely return an integer value, and that we are going to store inside r. Now what we will do, we will use a printf function to print the result. We will say factorial of %d is %d, escape sequence, new line, and factorial of a is r. Understood? Now see, if we run it, we will have the factorial, right? So this is a way where we are using a user defined function fact the basically the task of this function is to calculate the factorial of a number which it will be supplied to itself, which will be supplied to this function fact. It will calculate or compute its factorial and it will return the result. The calling function will get back the factorial and it will print that. Here the calling function is main, right? So this is a way normally we do, because this is a block of code, this is a function, and this is also another function. So the main function here calling the fact. Now the recursion, what we were discussing, recursion is a special kind where a particular function call itself. Now see, instead of writing this function factorial like this, I can also, or we can also write the function in this way, where we will write int fact int n, right? Now here we will write that first we will take a condition. If n is equal to 0, it will return 1, right? Else what it will do, it will return n into fact of n minus 1. Now see this particular case where in this particular line the function fact calling itself. So this is we will call recursive call, and as the recursive call exists in this function, the function calling itself, it's become a recursive function, right? Now how this basically works, before that let's execute this and see that whether it's working or not. Okay, I forget to comment out this. See, it's working fine, right? So instead of 5, if I provide 4, it will also act, right? So see, the very same task it's doing here. This code was not calling itself, it's simply using a for loop to calculate or compute the factorial, but here we are calling the function fact calling itself to come compute the recursive call, and the result is here. Now how basically this is happening? So let's see that. Okay, and one another thing, that see that if n is equal to 0, then it will return 1. It will not call itself, it will simply return 1. So this particular condition is called base condition. Base condition, we will understand this, and important, this is very important thing in respect of recursive call, because it's, if you don't, if you provide this, basically you are avoiding infinite loop. We will understand this. Now see, first we are calling the factorial with the number 5. Now what will happen, first it will check whether n is equal to 5 or not. As n is not 5, n is not 0, it will return false, and then as if statement is false, it will goes out and it will execute this return statement. When it will execute this return statement, it will do like that. Again it will call the very same function factorial with a value 4. Again when the function will execute, it will check again 4 is equal to 0, no, so again this return statement will be executed, and it will again call factorial of 3, factorial of this function with the value 3, and it will repeat for the 3 also. In the case of this, it will also call the very same function with the value 2. Again the factorial 2 when executed, it will again call itself with 1. This time when it will be called with 1, now again it will go for call factorial as 0. Now when the factorial function will executed with the value 0, the base case becomes satisfied. So now n is equal to 0. As n is equal to 0, what will happen? That it will return 1. So basically what happened? It will return 1, and that 1 going to add, we multiplied with this one. So 1 into 1, it has become 1. Now this one will be multiplied with 2, it become 2, and this 2 will be multiplied with 3, 6, and this 6 will be multiplied with 4, right? We will have 24. Now this 24 will be multiplied with this 5, and we will have 120. We will have our result, right? So here what we doing, we are doing the very same thing. Understood? So now the as we are providing the base condition, because of that it's terminating somewhere. So this is the concept of recursion. Recursion is a process where a function call itself, and there is a essential condition is base condition that must be there to stop the recursion. Why? That if I don't provide this particular base condition, then it never stop calling itself. It keep calling itself, and it becomes it falls in an infinite loop. Understood? So this is a recursion. A function when call itself, it's become a recursive function. Okay, now we will discuss on storage class in the context of function. We already know that storage class determines lifetime of a variable. It's determine the location of the storage, whether it is a stack or a heap or a register, and also it determine the initial values. Means when you declare that particular storage variable, the initial value it will be determined by the also storage class. How many storage class we do have? We do have basically uh, four kind of storage classes: auto, static, extern, and register. The auto are the default, means if you not provide any storage class while declaring a variable, it comes under auto. What it do? It automatically allocate and deallocate that particular variable, and it also limited to the function scope. The variable what you actually declared as a auto, uh, its availability remain inside the function where you are actually declaring. We already have a discussion on this in our last session. Like instead of that, we also have a static. We can also declare a variable as a static. So the static mainly we will discuss this in this class. So static, when you declare a variable as a static, it returns its value between multiple function calls. We can also declare a variable as extern, which refer to mainly for the global variables when it is declared in another file. When you declared a variable as a register, it will suggest storing that variable in CPU register. Means when you do require faster access, so you can declare that variable as a register. Okay, let's an example. Let's take an example. Uh, suppose I want to create a user defined function counter. Okay, the counter will take no argument. It's what simply do, it simply declare a integer variable count, which is initialized with 0, and we will use increment it by 1, and we will printf the value of the count. So count count is equal to %d. Now what we are going to print count. This is a simple. We don't require any return statement as we have declared the function as a void as a return type, right? Now what we will do, we will declare our main function void main. Now inside the main, what we will do, we will call counter 1 times, right? And as function is void, declare the main function declare as a void, will return nothing. If you declare the return type as integer, you need to provide a return statement, otherwise it will give an error, return 0. Because if when you declare a return type as integer, it expect a return, so we are declaring a return type 0. Understood? Now see, executed, so it's actually returning, printing the value of the count. Now see, we have used the count, we have used increment operator, we have in the function. So what we will do, we will again call this particular function inside the main. Now see, let's run it. See, okay, so it will be much more appropriate if I add escape sequence and new line. See, it's so now see, the first time when it's calling the counter value will be initialized with 0 and it will be incremented to 1 and it will print 1. Again when it will be called, again the counter value will be initialized to 0 and it will be incremented by 1 and it will print 1. So as what it do, it automatically allocate and deallocated and limited to function scope. But we want that it retain its value. We want to retain its value. Now see that, as I told, that the default type of a variable is auto. So if I don't also provide auto, it will also behave like same. So whether you provide auto or not, ultimately it will be the storage class of a variable will be auto. Okay. Now what we want that first time when it will be called, it will be incremented. Second time what will be called, it will be again incremented. So we want that this particular variable count retain its value between the function calls. So to do that, what we require, we require static kind of variable, because when we declare a variable as a static, it retain its value between multiple function calls. So what we will do, we will declare it as static. Now let's see what is happening. See, now this time, first time it is 1, second time 1 will be incremented again and it becomes 2 and it will be 2. See, if I again call this function, it will be 1 2 3. So that means now see, the moment we change the class of this particular variable from auto to static, it's retaining its value, right? So this is the concept of the storage class. See, so I think this is the end of the session. Thank you all for being with me to this entire session on function in C programming. Thank you.